Welcome back. This is Mr. Wakefield. We're talking about section 2.4 now, and we're going to start talking about actually doing some graphs ourselves instead of just talking about them like we did in the last couple sections, where we just kind of looked at them and did some problems with that. Now we're actually going to start out with nothing and actually come up with the graph itself, actually be able to draw it. The most simple type of graph that you see in an algebra class, this is what we're going to do here, is a line, okay? And as you know, a line is straight. A line has arrows on both ends of it, and don't forget that all your lines in this section must have arrows on both ends of it because they are lines. So they're straight, they've got the arrows. And the minimum number of points that you need in order to connect a line, in order to draw a line through those points, is just 2 points. That's all you need. And so we'll keep all that in mind. But the next thing we need to talk about right now is how does lines relate to equations, okay? In other words, right here, see how it says graph each linear function. These equations do represent lines. I'll talk about that as well. But notice it says linear function. Linear is a reference to the fact that when you graph it, it's going to be a line, okay? Thus the word line inside of that word right there, linear. Now, what makes these equations lines? And that's an important question, because when we get to some problems later in the semester where we see other types of graphs that are not lines, okay, that they have curvature to it, like some of the graphs we saw in the last couple of sections. Why are we going to be able to tell that these are lines? Now, I know that here it says linear function, so we kind of know it's a line, okay? But in the future, they may not give you that little clue. And so I just want to let you know how we're supposed to know that these equations represent lines when you graph them. Okay, what makes them lines, and we're going to go back to the very first section that we did this semester, 1.4. Notice that these were called linear equations. There's a reason for that. It doesn't mean that we're graphing these and getting lines, okay, but there is a close relationship between these equations and the ones that we're going to do today. These ones, after you get rid of the parentheses, I want you to notice that after you get rid of the parentheses, look at this equation right here. Same thing over here after I get rid of the parentheses on this line right here. Notice that both sides look like polynomials. Okay, just a bunch of terms with pluses or minuses in between them, just like we talked about up here at the beginning of that section. Okay, but not only are both sides polynomials, but the variables don't have any visible exponents attached to them. It's not like x to the second power or x to the third power. No, it's just x. What does that mean, you guys? That means that it's x to the first power, right? Okay. When you have a polynomial on both sides of the equal sign and the variables have no visible exponents, okay, that means it's a linear equation. It doesn't matter if it's a one variable linear equation like this where you just got to get x by itself and solve it, or as we're doing in this section right here, if it's got two variables, okay, and you're asked to graph it. Either way, it's called a linear equation when, and you'll see it again here, you got a polynomial on both sides of the equal sign. This is a two-term polynomial, and this is just a single term. But notice that the variables are what? X to the first power and y to the first power. It would be different if, for example, let me just write down a separate equation here. Later on in the semester, we'll see something like this, you guys. Why is this not a line when I ask you to graph this later in the semester? Why would that not be a line? It's because of the x squared. You actually have a variable with an exponent that you can see. In other words, it's not x to the first power, it's x to the second power. So if you've got a variable where the exponent is not to the first power, that's automatically not going to be linear. And so we'll learn about what kind of shape that's going to be when you graph that later on. You don't need to know that right now. Okay, but all of these are linear equations, and therefore they are going to be lines when you graph them. Now, they call them linear functions because when you graph it, they are going to pass the vertical line test. Remember we said in section 2.2 that if you graph something and it passes the vertical line test, it's a function. And so, yes, these look like linear equations, but they're also linear functions because they'll pass the vertical line test. That's the only reason why they use the word function here. There is one type of line that is not a function. I'll show you that here near the end of the section, but most of them are going to be. All right, so we need to graph these things. It says use intercepts and a checkpoint. I want to stop right there. And a checkpoint. That's an optional thing right there. You don't have to do that because the intercepts are going to give you 2 points. And remember what I just said a few minutes ago. When you have 2 points, that's the minimum amount of points that you need, minimum number of ordered pairs that you need, in other words, in order to graph the line. And so the checkpoint would be a third point that's just kind of like an extra point just to make sure that everything's going along the same straight path like a line is supposed to. But that's completely optional, all right? It's just an extra thing that you can do just to make sure that everything looks right. Okay, what does it mean when they say find the intercepts? Okay, intercepts are when, and again, we'll get into this more here as we go along, but intercepts are when the graph, the line, actually hits either the x-axis or the y-axis, all right? If it hits one of those two things, that's an intercept. Okay, but that only happens when either the x number or the y number is equal to 0. So in order to find the intercepts, I'm going to make a little ordered pair chart here. What you got to do is you got to plug in x equal to 0, and then in a separate, completely separate situation, separate step, you plug in y equal to 0. Okay, because as it says up here, one method that you can do when you graph a linear function, this is only when you have both x and y, okay? See how the problem has both x and y, and I just want to make that clear here. When it has both x and y in it, on the second page of this section, you'll see one of these variables will be missing. It'll be missing, and so these methods don't apply. That'll have a separate type of method. But when you see both x and y right here, we're going to use one of these two methods. We're going to look at the first method right now. It says to plot two ordered pairs, but the way in which you do that, and usually it's going to be the intercepts, like it says here. Doesn't always have to be, but here they ask for that, so we're going to do that. But the way you plot these ordered pairs from the equation, usually, and certainly with the first method, this is how you do it, is you plug a number into one of the variables, and then you solve for the other variable by getting the other variable by itself. Okay, and in this case, we're going to plug in 0, but that's what you do. So if I plug in this right here, I then only have y left over, right? Okay, because the x is gone now. It's been replaced by 0. Notice, again, just like I taught you with functions, with f of x, okay, when you plug something into a variable, put a parenthesis there and then stick the number 0, in this case it's 0, inside of that. Okay, now the way to solve for y is, first of all, I want you to take, if you have a polynomial on both sides, this is definitely what you want to do. You want to take the term that you just plugged the number into and figure that out first. And 8 times 0 is 0, right? What that does is when you plug 0 into a term, you guys, what it's basically going to do is it's just going to make that term disappear. And I know that because 0 minus 2y is negative 2y. So it's as if that 8x term was never even there, right? See how it just kind of just went away? It's as if the 8x just kind of disappeared into thin air and all you have left is negative 2y equal to 12. That's what happens when you plug in 0. That doesn't happen when you plug in other numbers, but it does when you plug in 0. So that's kind of nice, all right? Just like 0 minus 8, though, 0 minus 8 would be negative 8, 0 minus 10 would be negative 10, 0 minus 2y would be negative 2y. And so that's why it comes out like that. Okay, and we'll see that when we plug in y equal to 0 separately here. But then I solve for this, and we know that when you have again, a single variable term on one side and a single constant term on the other side, that's when you divide out, right? Like that. And we get y equal to negative 6, right? And so what that means is this. That means that since I plugged in x equal to 0, and I got -6 as an answer, kind of like what we were doing with f of x, that means that 0 and -6 pair up together as an ordered pair. Okay, and then that's one of your ordered pairs of your function, just like we saw with functions before. Okay, where is that on the graph, 0, -6? Well, x is equal to 0, which means it's right here on the y-axis. But the y is -6, so that's right here. Right here where that arrow is right there, -6. You don't need to say -6 right there. I can tell just by counting that's -1, -2, -3, -4, -5, -6. Okay, that's enough to see that that's what that is. You can change it to being -2, -4, -6, something like that. In that case, you'd have to tell me how you're changing it. But if you're just doing the normal -1, -2, -3 kind of count like that, then you don't need to write this number here. I'm just doing that since I want you to see on the paper what I'm doing here. Okay, but that's going to be one of the points for the line. All right. We need 2 points to connect a line. They also told us to do both of the intercepts, both the x-intercept and the y-intercept. Notice that this is the y-intercept because it's where the line is going to go through the y-axis. That's called the y-intercept. Okay, it's where it intercepts or goes through the y-axis. All right, y equal to 0. If I plug that in, what do I get? I'll do that down here. 8x minus, and then you plug in the 0 where the y was, like that. Okay, remember what we said. The first thing you do after you plug a number into one of the terms of an equation that has a polynomial on both sides is just figure out what that term is equal to. -2 times 0 is 0. So this is 8x plus 0. You don't have to write this down, this step right here, but what is 8x plus 0? Anything plus 0 is 8x. So as I promised you in the last part of the problem up here, okay, when you plug 0 into a term of a polynomial equation, okay, it's just going to have the effect of making that entire term disappear. It's as if the -2y was never even here, right? Okay, so you can just skip from this step all the way down to here. You don't have to write down this. I was just emphasizing how it disappears. Then I need to divide out the 8 because we have a single variable term and a single constant term. Okay, so that's the step where you divide out on a linear equation. 12/8, if I reduce that fraction, because it doesn't divide evenly, it would be 3/2. Now you might be wondering, how in the world do I graph 3/2? Okay, it's a fraction. There's multiple ways to do it. The easiest way, I think, is to make that into a decimal, and you could put that in your calculator. Make sure to do it the correct order, though. You got to say top divided by bottom when you convert it to a decimal. Don't say 2 divided by 3. You got to say 3 divided by 2. So 3 divided by 2, if you put that in your calculator, is 1.5. Now, 1.5, since it's 1 point something and it's positive, that means that it is somewhere between 1 and 2 right here. Okay, so here's 1, here's 2, here's 3. So it's going to be somewhere in there. I'm not going to pull out a measuring stick and make sure that you do this absolutely perfectly. If you get a decimal that's supposed to be between 1 and 2, just put it somewhere between 1 and 2 there, and that'll be good enough. All right, that's good enough for me. All right, just make sure you put it in between the correct two things, though. All right, if 1.5 is between 3 and 4 over here, obviously that would be wrong. But as long as it's between 1 and 2, all right, that's all I care about. So now you guys, you've done both of your intercepts. You have now got 2 points, which is what you need to graph a line. All you have to do at this point is draw the line. Just make sure it's straight. Okay, I'm going to use another pen here. You could use anything you want that's straight, just to make sure that it's straight. And what is the other thing we need for a line besides it being straight? It needs to have arrows on both ends of it, right? So there you go. Straight, arrows on both ends of it. Okay, to wrap up this problem, though, to finish this off, what is the purpose of drawing this line? What did we just accomplish? All right. I told you that this is supposed to be a line, but why is it a line? It's because when you graph a line, assuming that it is a linear equation, okay, and it's supposed to be, which would make it a line, what happens with the linear equation is that after you graph your line, what is true, and you don't need to say any of this on a test or homework question, I'm just letting you know the purpose of this because it's good to know that. Just good for your own knowledge. But every single point on this graph, again, you don't need to highlight these points. I'm just making a point here about the problem, the purpose of it. Every single point on this line, you guys, is a solution to this equation. In other words, if you plug it into this equation, it would make it true. It would make it true. Just like if you plug in x equal to 0 and y equal to -6 at the same time, it would make this true. That's what a solution is. Okay, 8 times 0 is 0. Minus 2 times -6, that would be 0 plus 12. Negative 2 times -6 is 12. 0 plus 12 is 12. It makes it true. Okay? And so my point is that all of these points do that same thing. All of these points make it true. It makes the two sides equal if you were to plug them in. Again, you don't have to plug it in, but you understand now what the purpose is of what we just did. This line, like any graph, you guys, is an illustration of all of the different solutions to this equation right here. So when we were solving those equations all the way back in section 1.4, the first day of class, and we got this answer right here, like for example, x equal to 9 over -2, okay, something like that. And most of those one variable equations are going to be like that right now, where it'll have just one answer like that. These ones have an infinite amount of answers. Okay, all of these are solutions. Okay, so unlike here, where you just had to say x equal to this and circle it, since there's an infinite amount of answers, you have to graph it. You can't just list them all out on your paper when there's an infinite amount of them. That's the purpose of doing graphs. It's to illustrate all of the solutions because there will be an infinite number of them. Okay. Now, I'm going to ask you guys to try these two problems right here. Okay. And you need to do the same thing. You need to plug in x equal to 0 and y equal to 0. X equal to 0 and y equal to 0. Okay, figure out what those what numbers pair up with that. Doing the same thing I did over here, and I'll show you those answers here in just a moment. All right, at number 1 right here, we end up, if we plug in x equal to 0, it pairs up with -6. Let me show you how that happens. As I told you guys, when you plug in a 0 into a polynomial equation, it has the effect of just making that term disappear completely. And so it just ends up being -y equal to 6 because the 2x is just going to become 0. So -y equal to 6, you divide out the -1 to get the y by itself, and that's why y is equal to -6. If I then do the same thing here when I plug in y equal to 0, that has the effect of getting rid of the -y term. Remember, the negative is part of the term there because it's plus -y, all right, as we talked about in 1.4. So that has the effect of making that entire term disappear, and you're just left with 2x equal to 6. Solve that, and you get x equal to 3. I then plot those 2 points, 0, -6 down here, 3, 0 down here or up here, and you now have your 2 points that you can connect with a straight line that has arrows on it. Same thing over here in number 2. Okay, if I plug in x equal to 0, it makes this term here disappear. However, what's different about this problem is that we have a little bit more work to do here because the 0 and the -15 are on opposite sides of each other. And so you need to get the two green, because here's the thing, you guys. Once you make one of those variables disappear by plugging in a 0, it becomes a linear equation like we did back in 1.4 here. So I'm going to do the same steps that I did in 1.4 after I plug in that 0, because you now have a one variable linear equation. A linear equation that now has only one variable left. And so I'm going to do the same steps. That means to add the 15 over with the 0, divide out the 3, and that's where the 5 comes from right here. Y equal to 5. If you then plug in y equal to 0 here, it makes the 3y term disappear. All right, it makes this term disappear, and you're just left with what? 5x equal to negative 15. And I wrote that down right here. Solve that, and you get negative 3 comma 0, which would be this point right here, and I wrote it down right here. I then plot those 2 points and connect it with my straight line with arrows. And that is how you use intercepts to graph a linear equation, or in this case, also known as a linear function. All right? The second method that we have, as I go back to a clean sheet here, is it says rewrite each linear function in slope-intercept form if necessary. Sometimes it'll already be in that form. Then identify the slope and y-intercept, and finally graph the line. Okay, got some new things we got to introduce here. First of all, what is slope? Slope measures how steep the line is. Okay, and it comes in a number of different forms. Let's simplify this as much as we can. Slope. Slope could either be positive or negative. There's a couple other things it could be as well, which are not related to these normal equations that have two variables in it, x and y, x and y. And yes, this is also x and y, remember, because f of x, remember, f of x, you guys, is the same thing as y. Remember we talked about when you figure out what f of x is equal to, it ended up being the y coordinate. So I am allowed, you guys, I'm actually allowed to change the f of x to y. Okay? The whole thing just becomes y because it is the same thing as the y coordinate. All right? And so you're allowed to do that. But when you have both x and y in your equations, okay, your slope is either going to be positive or negative. So let's take a look at these two scenarios here. When you get a slope, when you figure out what the slope is, you're always going to have just a single constant number on top and a single constant number on the bottom. When that happens, you could get any one of these 5 different fractions here. Any one of these 5, depending on where the negative signs are, or sometimes there won't be a negative sign at all, like in this one. Okay? If it looks like this or this, it's going to be a positive slope, because positive divided by positive is positive, as you know. Negative divided by negative is also positive. So that makes sense, okay, that would be positive. We'll talk about what to do with a positive slope in just a moment. If you have a negative on top only, or if you have a negative on the bottom only, or if you have a negative on the outside of the fraction only, okay, nowhere else, then that ends up being a negative slope, all right? And so watch out for that as well. Okay, now, when you have this situation, either positive or negative, let's start out with positive. Okay, that means that as you're going from one point, let's say this is one point on the line right here, okay, right here. And the line goes like this, all right. In order to go from one point to the next point, in other words, you can figure out another point on the line if you want to by going rising 3 and running 5. In other words, if the slope is positive, whether it's in this form or this form, that means to go from one point to the next, you can rise and run. And when I say run, you guys, very important, so there's no confusion, I mean running to the right. I don't mean running to the left. Okay, that would be a completely different location, and you would get you all messed up. So when I say rise and run, I mean rise and run to the right. Negative is almost the same. Okay, if you get any one of these 3 possibilities here, it means that you would drop. I didn't mean to put that there. Hold on. So you start here, and you're going to drop and run to the right. Drop and run to the right, and then your line would go like this right here, because it would go through those 2 points right there. Again, that's if it's a negative slope. All right? So it all depends on whether or not it's positive or negative. We'll practice all this, don't worry, and plenty of problems here, but I just wanted to give you an introduction to that. So the second method then says what? It says if it's not written in this form already, write it in this form where notice that y is by itself, you guys. It is by itself. And then on the other side, the x term is first. The coefficient of the x term is the m, which is also the slope. Okay? I'll get into that plenty more here, don't worry. So you got y by itself. You got the x term that is the first thing on the other side. The coefficient of x being multiplied by x is the slope. And then plus this thing right here. This thing right here is going to be the y-intercept location. Okay, so m is the slope. The b is the location of the y-intercept on the y-axis. Don't worry, again, we'll go over that plenty here. All right. So anyway, let's look at this first problem right here. Notice in the first problem that y is by itself. You have the x term here. Yes, 3/4 can be a coefficient just because it's a fraction. That doesn't matter as long as it has no variable inside of the fraction. Because remember, coefficients aren't supposed to have variables in them. They get multiplied by coefficients. You know, like if you have like a 2 times x, 2 is a coefficient. It's multiplied by the x, but the 2 itself is a constant number. That's the coefficient being multiplied by the x. Well, it's the same thing with 3/4. 3/4 doesn't have a variable in it, so it's a coefficient being multiplied by x also. And then this here, yes, it says -3, but it's the same thing as plus -3. So it fits right into this mx plus b. Let's bring it up here. Y equal to 3/4 x. And you don't have to write this down, but just to emphasize it, plus -3. That's the same thing as -3 there. So you'll notice that the equation we're currently working on is just like this right here, which means it's in this form perfectly. And the y is by itself. You've got the x with the constant number being multiplied by it. That would be the m right here. And then the plus, and so then the b would be -3. What does all this mean? Well, once you have it in this form, and you must get it into this form first, you cannot do any of these other things, steps B, C, and D, until you do get it into this form. But once you do, then you, as the directions say, it says then identify the slope and the y-intercept. Okay? So the slope, because it's that m number, you know how it's supposed to be mx, since it's that m number, the slope then must be 3/4. Okay, so the slope is that constant coefficient that's being multiplied by the x after you get it into the correct form. Now the y-intercept, in other words, where the graph crosses through, where the line crosses through the y-axis, okay, that's going to be not 3, but -3. Okay, -3. Okay. So once you know what the slope and y-intercept are, that's the next step. Finally, it says graph the line. We're going to do the graph a little bit different than the graphs up here, okay, that we did just a few moments ago. What we're going to do instead is, if you know what the slope and the y-intercept are, you guys, you go like this. You first of all locate the y-intercept. Okay. There's -3 right there. Again, it's got to be on the y-axis. That's why we call it the y-intercept. It's not the x-intercept. And then since the slope is positive, as I just mentioned a moment ago, if it's positive divided by positive with no negative signs, that's a positive slope. And so what's it going to do? It is going to rise 3 and run 4 this time because it's 3/4 instead of 3/5. So rise 3 and run 4. Let's do that right now. Okay, we're going to rise 3, so we're going to go 1, 2, 3. And then from that point, we're then going to run 4 to the right, 1, 2, 3, 4. And then, like I said, that's how you can go from the first point to the second point of your line. Okay, so we're still creating 2 points like we did in the previous problems up here. It's just that you're starting out with the y-intercept as your first point. And then you're doing this rise and run thing. Sometimes it'll be drop and run if it's a negative slope. But otherwise, you are doing the rise and run thing in order to get to the second point on the line. And then once you get that second point, you guys, then you as always, draw your line. Again, make sure it's straight. And make sure it's got your arrows. Like that. There we go. And that's it. So we use the y-intercept for the first point, and then we use a slope to go from the first point to the second point, and then you'll have both points. Okay, now, in the next problem here, there is a situation here where y is not by itself. So they want you to get into the slope-intercept form. Again, the slope-intercept form is this y equal to mx plus b form, so you need to get the y by itself. Now remember, and we kind of learned about this in that section where we had the formulas, you know, with all the different variables in it, and you had to get one of the variables by itself. We learned in that section that if you have a variable that you need to get by itself, that's called the variable term. All the other terms, even if they have a letter in it, they are considered to be the constant terms because they don't have the variable in it. And you need to, assuming there's no parentheses to clear out first, you need to move the green ones to the opposite side of where the red one is and then divide out after that. All right, we did that again back in section 1.5 in the second half of that, where again you did what here? You had, if you had a couple of greens and then a red, you added or subtracted the two green ones to the same side, and then after the red one was by itself here, you divide it out. Same exact thing that we're doing here. Same exact thing. So you subtract the 2x over since 2x is positive. Please put the 2x in front of the 4 though, okay? Because the x term goes first here. All right, that way you'll be able to get it into the exact right form here. And since 4 is positive and negative 2x is negative, we say negative 2x plus 4. All right. Officially, it's 4 minus 2x, but we wanted to reverse it around. And you're allowed to reverse terms around, okay, when you are, as I'm sure I've said that before, but you're allowed to reverse terms around that are being added or subtracted together as long as they still have the same correct sign in front of each one when you put them in their new order. And you got to have a plus or minus in between the terms still, because they were not like terms, so you got to keep them separated by a plus or a minus. That's why you got to put that plus there, even though it didn't have a plus in front of the 4 before that. Okay, the 4 is no longer the first term here. It's no longer 4 minus 2x. So you got to put a plus or minus in between it there. All right. But notice that it's now in the correct form here, isn't it? Okay, you got y by itself. Negative 2 is your m, constant coefficient, being multiplied by x, and then plus 4. So that means what? That means that the slope is negative 2. No, I know that's not a fraction, but we can make it into one. I'll get back to that in a minute. And then the y-intercept is 4. Now remember, if something is not a fraction, you guys, you can easily make it into a fraction by just putting it over 1, right? So negative 2 over 1 is your slope. You can also just call it negative 2. I'm just making it into a fraction so that you can then do that, rise and run or drop and run thing. Okay, but officially it's negative 2. You can say that as well. Since the slope, though, is negative, because it's a negative... Sorry, that fell off the screen there. Let me bump this up. There we go. Since it's a negative divided by a positive, that means that it's going to be a negative slope. And since it's a 2 and a 1 here, not including the negative, okay, that means that we're going to drop 3. Pardon me, I'm looking at this thing here. Excuse me. We're going to drop 2 and run 1 because it's a negative 2 and a 1 there. Okay, so you're going to, since it's a negative slope, irregardless of where the negative signs are here, if it's any one of these 3 fractions, you are going to drop and run. So you're going to drop 2 and you're going to run 1. Okay, but before you do that drop and run stuff, as I mentioned in the last problem, you've got to have a place to start from. All right, and since the y-intercept is 4 here, you always start with that when you're doing this method. Okay, So we start out with the y-intercept, and then because we're supposed to drop and run, let me count that out here now. You're going to drop 2, and then you're going to run 1 to the right. Okay? Drop and run to the right when it's negative, and then I now have my 2 points, so I'm going to use my pen here as a straight edge here so I can draw a straight line. There we go. Put your arrows on it and you're good to go. Okay, so that's what happens when you have a negative slope. There it is. Sorry about that. There it is right there. Okay. Okay, coming over to problem D now, you see a similar thing going on where the y term is not by itself. We need to get it by itself. All right. So we need to take these other 2 terms that don't have the y in it and get them onto the opposite side of where the y term is. That means to subtract the 7x over. Again, put the x term in front of the 14, so it's going to look like what here? It's going to look like 2y equal to negative 7x, and then put that plus in front of the 14, because you got to have a plus or minus in between those terms. Since they're not like terms, you can't combine them. Got to have a plus or minus in between then. And since 14 is positive, that's why it's plus instead of minus in front of the 14. I then need to divide out by the 2. Again, very similar to back in 1.6. Again, just to give you a visual here. Had to divide out at the end to get the m by itself after the 2 terms were on the other side. They weren't like terms, but that's okay. You can still divide out. Okay, the answer is just going to look a little bit different than normal, a little bit more complicated, but the important thing is that you got the variable by itself so that the variable also is not on the other side of the equal sign. And that's what it means to solve for a variable. Same thing with the y right here. Okay, if we divide by 2, we'll have a y solved for. Okay, y will be solved. So the 2's cancel out there. You get y equal to what? Well, I could say it that I could keep it this way normally, but we're going to do this a little bit differently here so that it will be in the mx plus b form right here. No, I'm not going to cancel because, like I told you, until we get to chapter 6, you can't cancel until pardon me, you can't cancel if there's more than one term on the top here. All right, so you can't cancel the 14 and the 2, for example. But what we're going to do instead, in order to get it to look like this, is we're going to do a division step. Let me review that with you if you haven't seen this, or if you haven't seen this in a while. When you have 2 terms, a 2-term polynomial on top and just a single term on the bottom, you are allowed to split it apart like this. Okay, where you take the first term divided by the 2, and you take the second one and divide it by the 2. But you've got to have a plus or minus in between. And so since this is positive divided by positive, that's going to be a positive answer. And when that happens, you need to put a plus in front. If it had been a negative answer, you put a minus in front. And then what you do is you don't put any negative signs inside of the fraction, even if there were some here. You just put either a plus or minus in the front of it based on the sign of the answer. So since these 2 things are positive divided by positive, it's going to be a positive answer, and therefore you put the plus in front. You don't need to put anything in front of the first one here. It's just the second one that you need to do that. Okay. Let's simplify each fraction now, and we know how now through our exponent rule section. We know how to simplify fractions. We've reviewed that. If I put this in lowest terms here, it would be 7 over 1, okay, which is going to be 7. So I'll just say plus 7. You could say 7 over 1, but this is not a slope, so you don't need a fraction. This one is a little bit different, though. Okay. And by the way, you cannot cross-cancel over a plus sign. I want to make that real clear. Don't cancel the 14 and the 2. You can only cross-cancel over 2 fractions if the fractions are being multiplied. Again, that's another thing we'll deal with more in depth in Chapter 6. But right now, don't cross over a plus or minus sign when you're canceling with two fractions. All right, so keep the fractions separate and put them in lowest terms. This is already in lowest terms. You can't cancel the -7 and the 2. There's not another x to cancel with this x up here. But there is one other thing that we need to do in addition to actually putting it in lowest terms, and that is you need to separate the x, like it says here. You need to separate the x from that fraction that does not have any variables in it, okay, so that you'll be able to see what the m is equal to. Okay, so if you've got an x term on top and a 2 on the bottom, and you need to get it into mx plus b form, and you actually have the y by itself already, I'm not talking about a previous step here. I'm talking about when you got y by itself, you've got the two fractions separated over here, and you need to get it to look like mx plus b. What you need to do in that case is you need to separate the x from the rest of the fraction, and it is okay to do that because the x is being multiplied by the rest of the numerator here. It is okay to do that. If this had been -7 plus x, you wouldn't be allowed to do that. Okay, but it's not. So you're allowed to put that behind the fraction, and then that clearly indicates that the fraction, or that this right here is the m. I want to make it very clear, you guys. I know it looks like the -7 is the m, and it looks like that because it looks like -7 times x is the same thing as m times x. But you can't ignore the 2 underneath. Okay, so that's why you got to separate the x from the entire rest of the fraction here, and then the fraction becomes the m. Okay, very important. So when you got an x on the top of the fraction there, you've got to separate it on this step here. All right, and then the fraction that is now in front of the x, that becomes your m, because there's no variable in that. And remember, m cannot have a variable in it, so you got to separate the x, and then that fraction with no variable in it becomes your m. But as you know, m is the slope, right? And so the slope is -7/2. And as you can see there, the y-intercept is 7, because plus b and plus 7 are the same thing there. And so the y-intercept is +7. So once we have the y-intercept, there's 7 right there. Just make sure these things are equally spaced apart here. Okay. That's part of what's required here. 1, 2, 3, 4. Just like 1, 2, 3, 4, 5, 6, 7. Those numbers are equally spaced apart. Okay. The marks must also be equally spaced apart. In other words, you got to count 1. You got to add 1 to get to each next mark. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. And so that's why it makes sense that all these have to be equally spaced apart here. Okay. So I start out with the y-intercept. As always, we did that in the last couple of problems. And then -7/2, that fits into this description right here where it's negative divided by positive. And so we're going to drop 7 and run 2. Drop 7 and run 2. If I drop 7, I'm going to get all the way down here to where it's in the middle. That's called the origin. That's where it's 0, 0 on the ordered pair, by the way. But that's where you turn. That's where you stop dropping at that point. You start running. You run 2, and so that'll bring you to here. And there you go. Okay, so we're gonna drop 7 and run 2. Now that I've got my 2 points, as always, I draw my straight line with arrows. Okay. Like that. And that is your line there. So please try problems 3 and 4 right now. They're very similar. One big difference, though, that I want to just give you a heads up on here is number 4. It looks like it's missing a term there, doesn't it? Okay, and the previous 4 problems, including number 3, there's 3 terms, right? There's an x term, there's a y term, and then there's a term with no variable in it. Well, this one is missing the term that doesn't have the variable in it, which is where the b is going to come from. Okay, so what that basically means, and I'll show you how this all comes out here. Go ahead and give it a try for right now. But what that means is that the b is just going to be 0. Okay, let me just go ahead and get it started here for you. Why not? So we need to get the y by itself, right? So I need to divide out because we have just a single red term. And we got the single green term here, right? And so that's why it's a division step, because the reds and greens are on opposite sides. You divide at that step, and we get what? We get y equal to 4/3 x, and that's it. Well, because the b term is missing, you are allowed to say this right here. If you forget to say that, that's okay. As long as you know that the plus 0 is there, whether you keep it invisible or you actually write it, as long as you know it's there and you know, therefore, that the b is 0 as a result of that, then that's what's important. So you can now clearly see here that the m is 4/3, okay, and the b is 0. Why did I end up with x on the outside there again? Okay, it was 4x over 3, right? Well, remember I said that when you get the y by itself, if you got the x in the numerator there, you want to separate that from the rest of the fraction, just like I did up here. Okay, and that's what tells me that the slope is not 4 only, it is 4/3, because you got to put the x behind the slope. All right, you can't just forget about the 3, in other words. Okay, so the 3 is a part of the slope, they're not just the 4. All right, so go ahead and finish that problem off. Also do number 3. Hit the play button after that, and we'll take a look at the answers. Okay, let's take a look at number 3 here. Again, we need to get what? We need to get the variable term, which is negative 2y, on the opposite side of where the other two terms are. That's why I subtracted the 5x over. Okay, so we ended up with negative 2y equal to negative 5x plus 10 by subtracting over the 5x here. I then need to divide out the negative 2 to get the y by itself. Okay, and I kind of skipped a step there, so let me make sure everybody sees that. Remember, when you got the two terms here, after you get the y by itself, if you've got the two terms and then a single term underneath it, you go like this. Okay, you do the first fraction, the first term divided by the term down here, and then just like we did in problem D, and then here, since this is positive divided by negative, I'm going to put a minus in front, but you don't put the negative inside, okay? Otherwise, you'll be doing too many negatives there. You don't want that. Positive divided by negative is negative, so we put the minus in front, and then we just say 10 divided by 2. No negative inside the 2 there. All right? And that'll ensure that your signs are correct. And then what you do is, like I said, when you got the x in the numerator here, because it's being multiplied by the negative 5, you are allowed to what? You're allowed to separate it like that. Go ahead and put this in lowest terms over here. And that would be 5 over 1, which is the same thing as 5. Bring down the minus in front of that. And then you're pretty much done. You can change the negative 5 over negative 2 to just 5 over 2, because as we said in the directions here for positive slopes, negative over negative is the same thing as positive over positive. And so you can change negative 5 over negative 2 to 5 over 2. I'm okay if you don't do that. You can keep it as negative over negative. That's okay, but I'm just telling you can do that. So the slope is 5 over 2. The y-intercept is negative 5. I just called it m and b here. That's fine. But what's important is we know what they are. We always start with the y-intercept in this problem. And then because this is a positive slope, we go from the y-intercept to the next point by doing what? By rising 5 and running 2. Rise and run when it's positive, correct? Okay, so I rose 5 and then I ran 2. And that gave me my second point right there. Okay, as you can see, I colored in there. And then I drew the line. All right, so that is number 3. Number 4, as we already talked about, y is equal to 4/3 x plus 0. Because that term was missing, we said it was plus 0. That means that the b is 0. Again, the y-intercept is, the slope is positive because it's positive over positive. And so we're going to rise and run again. So since the y-intercept is 0, we start here. That's 0 on the y-axis. And then we rise 4, and we run over 3 to this spot right here. And then we draw a line. And so that is how you use the slope-intercept, the slope and the y-intercept, to graph an equation. Okay? And so those are the two different methods that you use when what? When you're graphing a line and the equation rather has both x and y in it, okay, you're going to use one of these two methods. If they tell you to use the intercepts, then use the first method. If they tell you to put it in slope-intercept form, then use the second method. Okay, as the second method clearly indicates here, to use the slope-intercept form right away. Okay, but that's what you do when both of the variables are there. As you'll see on a couple of problems here on the second page of section 2.4, however, and let me pull that out. Like I was saying, what's different here on the back is that there is a variable missing. Okay, here you can see that the y is missing. And here, I know it looks like the y is missing here as well, but it's not, because remember what we said. F of x is the same thing as y. So this equation actually says this. It says y equal to -4. Y equal to -4 officially is what this thing is. And so the x actually is missing here, even though you originally saw it, because this is the same thing as the y coordinate right here that I circled, f of x. Whereas here, it's the y coordinate that's missing. Now, on the front side of the worksheet, like I said, when both variables are visible, you do one of these methods. But if one of those two variables is missing, we got a whole different situation. Okay, let's read the directions. If you've got a linear equation where the y term is not appearing, it's invisible, all right, like this problem right here, and the x term does appear, that's always going to be a vertical line. I'll explain why it's a vertical line in a moment. But first of all, a vertical line is what? A vertical line is when it goes straight up and down. Okay, it doesn't move to the right, it doesn't move to the left, it's just going straight up and down like this right here. Okay. Whenever you get a linear equation in which the x term is invisible and the y term does appear, like this one right here, you see the y but you don't see the x, that resulting graph is always a what? It is always a horizontal line. Horizontal line is the ones that go straight across. Okay, like a number line does. We've seen some number lines already this semester. They don't go up or down at all. So in other words, you guys, when you have a problem where both x and y are visible in a linear equation, then the lines will always be diagonal. They won't be horizontal. They won't be vertical. They'll always be diagonal. You can see that all these are diagonal here, right? On the first page of the 2.4 worksheet. But here on the second page, because a variable is invisible, it will either be horizontal or vertical. So how do we graph these horizontal and vertical lines? Thankfully, it's actually simpler to do. The biggest concern is making sure you don't mix these two things up. Okay, make sure that you don't do horizontal when it's supposed to be vertical, for example, and vice versa. So when you have a variable missing, what you do, if it's not done already, is you solve for the variable that you do have, get it by itself. And since you have a variable term here and a constant term here, just one of each term, that's the division step here, like always in a linear equation. And that gives me what here? That gives me x equal to -3, right? Okay. And so here's what you do. You go over to -3 on the x-axis, not the y-axis, because this is x equal to -3. Okay, and then you just simply draw you can put a point there if you want. You don't have to. What's important is that you draw a vertical line through there. Okay, nice straight line, okay, with the arrows on it like always, but it's vertical. Why is it that it has to be vertical this time instead of horizontal? Well, notice that every single point, I mentioned this briefly before in another section, but every single point on a vertical line has the same x. Like, for example, this point right here. This point right here is negative 3, comma 1. Okay? This point right here, is negative 3, comma 2. Okay, all of these points here have x equal to negative 3. It's just that the y's are different, but the x's are the same. Okay, that's a vertical line. All right, a horizontal line is when all the y's are the same. I'll show you that in a minute. But every single vertical line is always going to have the same x. And so it makes sense that when x is the only thing you got and there's no y, it makes sense that all the x's would be the same. Remember that. Okay, if x is all you got and the y is invisible, that means all the x's are going to be the same. And then that'll remind you that, oh yeah, that's the one that's a vertical line. That's not the horizontal line. That's the vertical line. Okay? So I'm just trying to help you remember this so you don't get the two different things mixed up, horizontal and vertical. When is it horizontal? It's horizontal when the y is visible, but you do the same basic idea you did over here. It's just that you do a horizontal line instead. The other thing that's different is that you go on the y-axis, not the x-axis, like this. You go down to y equal to negative 4. Again, you could put a point there. You don't have to. But what's important is that you draw a horizontal line through y equal to negative 4 because that's what y is equal to. Okay? So you draw a horizontal line. And again, why is it that this one has to be horizontal? I just want to help you remember this more easily. You don't have to explain it on a test question. You just need to give me the horizontal line. But the reason why horizontal lines are what you get when the x is missing and you only have the y is because all the y's are now the same in a horizontal line, whereas with vertical, all the x's were the same. Let me show you. Isn't it true that this point right here is 1 comma negative 4? This point right here is 2, x equal to 2, and y negative 4. So you've got right here 1 negative 4, 2 comma negative 4, 3 comma negative 4. See how all the y's are the same? The x's are changing, but the y's are the same. Okay? And so with a horizontal line, the y's are always the same, and that makes sense because y is all we got. So when y is all you got, the y's are always the same, and that leads to a horizontal line every single time. When x is all you got, that means the x's are always going to be the same, and that leads to a vertical line every single time. So this is what you do when a variable is missing. Okay, you determine if it's horizontal or vertical, and then you act accordingly, and you go ahead and graph the line. One last point here, you guys, that I wanted to make. All linear equations are functions except what? Except for the ones that are vertical lines. Okay. Remember we said that you can't have a set of ordered pairs where the x's are the same at all. When you have a function, we said that in 2.1, the x's can't be the same. Okay. Well, all the x's are the same here, so certainly that can't be a function. So vertical lines, you guys, are not functions, but all other lines are functions except for vertical lines. Okay, so just wanted to point that out as well. Okay, we may need to talk about that more in the future at some point. Okay, so this concludes section 2.4. We'll be talking more about lines, but just from a different perspective in the next section. But in the meantime, let me know if you have any questions. You have a good day, and you take care.